Okie dokie. So let's go. So I'll share my screen. Oh, I am sharing the screen. Am I? I'm not. There we go. Share screen. So can you see the lecture slides?
Yeah.
Good. Okay,
Yeah.
I'll just actually change the layout here as well. Get a better view of you guys. Very small audience today. Anyway, we'll see how we go. So this is on yet again on the supply curve. And the point I went through last week is the origins of the supply curve concept. It really was first drawn in Marshall in 1890. But then, of course, it's become just it's got to be the most successful meme in the history of humanity and also the most dangerous, unfortunately. So I went through the origins last week. What I now want to now do is show the way you go from the supply curve to the concept of diminishing marginal productivity, which leads to the idea of the marginal cost curve. And it's, even though people learn this stuff, they rarely, I think, have a complete understanding of how it's done. So this is why I go through it fairly laboriously here. So the idea is you first of all have you're producing output in a factory that has a certain number of fixed inputs that can't be varied across the time span you're looking at, this the so-called short run, and then a variable inputs, and you'll talk about labor and new materials and raw materials and stuff like that. But fundamentally, they just think about labor. There's no real thought beyond that point. And there's an ideal ratio of the variable input to the fixed input. When I want to have a bit of a go at this thing, this nonsense concept, what I'll often do is talk about shovels or what do you call them, pile drivers. There's one person per machine, but you can get more out of two people handling a machine and then 3 and 4 and 5, which is sheer nonsense, of course. But this is the basic idea. There's some ideal ratio. Now, as you first of all, you're using all your fixed inputs. That itself is silly, but I'll come back to that. And as you get more and more variable, you finally reach the ideal ratio. That's your maximum productivity. So when you do the graph of average variable cost, that's the minimum at that point. But then to get the higher level of output, you've got to put more variable in to the same level of fixed. And so you get more output per additional worker, but you're working beyond the ideal point now. So your productivity per worker falls. Still positive, but you're continuing to go backward. So if you graph, you have a supply curve that looks like this. This is your variable input. I'll go over this side now. Your variable input here is labor. There's the quantity produced. You have increasing productivity until you reach the ideal point, and then decreasing but still positive. So when you graph this in terms of the marginal product of labor, which is the rate of change of quantity, you get it rising for a while, reaching a peak, and then falling down again. Okay, so that's the basic idea of that's rising marginal productivity and then diminishing. And this is the part that's supposed to give you the supply curve. But the logic, you don't actually need that curve to derive the supply curve. So you start first of all with labor in the input and quantities the output. This is one of the few graphs that economists get the right way around. But then what you do is you flip the axes, basically reflected in a 45-degree line. And then what you have is, have quantity produced here and the inputs necessary to produce that input on the vertical axis. But once you've got that, and you also have the assumption that the hiring practices of the firm don't change the wage level, you simply multiply labor by the wage rate, and there's your variable cost curve. Okay. To get your total cost, you simply add in fixed costs. That's over here. So you whack in fixed costs, which of course are constant at this level, the quantity, and now you've got total cost here. And then you calculate the slope of that curve, and that's just basically, take the differential, and the first of all, it flattens out, then it gets steeper, and that is what gives you falling and then rising marginal cost. So that's the basic logic. Tony, yeah? Well, you're working out the logic. Okay, thank you. All right, yep. Okay. Now, then you have a market price that you assume doesn't change given the output of the firm. So you now have total revenue and total cost. So there's your total revenue, which is a straight line because you get the same price no matter how many units you sell. And then your marginal cost, and now doing this, that's total revenue, which is price times quantity. This is just price, independent of quantity on the bottom axis. Then you have fixed costs, and that's going to be average fixed cost down here. So if you divide fixed cost by quantity, you necessarily get a rectangular hyperbola. Then you have your total cost curve, which is the sum of fixed costs plus variable costs. And for all here, you're losing money. Just between these 2 points, you're making money. That then gives you an average cost down here. So I've only, drawn part of it. So that's the point where they're both equal down here. And then you have marginal cost, which I derived in the previous diagram. And then if you drop a dotted line down from where total revenue equals total costs, that's also where average revenue equals average costs. Then you have the other extreme where rising marginal cost has driven up the average cost of production. So here you have average cost and price being equal again. And up here it's because total revenue equals total cost. And what you want to find is the maximum profit point, which happens to be there. And that is where marginal cost equals marginal revenue. And then that's the slope of that curve. So when the slope of the total cost curve is the same as the slope of the total revenue curve, you maximize profits. That's the basic logic. So the point where price equals marginal cost, which is down here, identifies where the slope of these two curves are the same. And where you reach that point, you have maximum profit. Okay. So that's the logic. And this is what economists think is really advanced and cool thinking. Now, before I go to mathematical form, I want to show some slides to you, which are taken from standard textbooks. I just want you to think about what is strange or common about each of these. So you'll find lots of textbooks which just basically draw diagrams and don't have any numbers on the axes. And in fact, I gave a talk at a Budapest interesting little students research group yesterday, and they use Varian, and Varian just has drawings. It doesn't put any numbers on the axes, so you can draw anything you like. This is with Mancues. Okay? So he has rising marginal costs, rising average total cost, etc., etc. Here is from Blinder and Nordhaus. There's Blinder. I like the way he uses graph paper here, very precise. Okay, so you have marginal cost and marginal revenue, point of intersection, maximum profit, and then you have Nordhaus that does what I've done on the other side, having total on the one vertical and average on the other. So what is strange? Can you spot anything there that is peculiar? Any guesses?
Numbers are incredibly small.
Yes. Okay. I'll get onto this, why this matters later. But 10 glasses of lemonade an hour? I mean, one of my young nieces could manage that. Okay? In a factory, give me a break. 10 garages per year. What's this? I'm not quite certain what he's supposed to be selling, but it's really small numbers. And there's a mathematical reason for that, which neoclassicals are not aware of. They bullshit their way around it. They think they know what they're doing. Of course, they don't. Now, the key assumption that is also glossed over is a homogeneous product. Okay? And I'll come back to talk about that in more detail later. And you then have, with the idea of perfect competition, which I'm now going to lead up to why that's so important to neoclassicals, total revenue is price times quantity, where they assume the price doesn't change for a competitive firm. You have total cost being fixed costs, which I'm going to use F for, variable costs, which are VC, and variable costs don't have to vary, but they are, if they do vary, they're a function of the quantity produced. And profit is the gap between the two. So your profit is total revenue minus total cost, and that's price times quantity minus the sum of fixed costs and variable costs of the given quantity. So you then differentiate because you're trying to find where this is zero. So the differential of rate of profit is the differential of price times quantity minus the differential of fixed costs plus variable costs. And then when you expand this out, this is now the chain rule. So P times dQ dQ, which is going to be 1, plus Q times dP dQ, which in the model of perfect competition is also 0. Differential of fixed costs, well, they don't change, so that's a 0. And this is the differential of variable cost, which is marginal cost. So that one ends up being 0. So that's now 0. So you now have price. This is obviously 0. If this doesn't change, then that's also 0. So you finally find your differential of profit is price minus marginal cost. And you maximize where the differential is 0. So your maximum profit occurs where price minus marginal cost equals 0, or where price equals marginal cost at an equilibrium quantity. Okay? That's the basic logic they go through. Now, what that did was explain what Marshall had just drawn, because Marshall basically drew this and didn't really have an explanation for why what the supply curve was and why it rose with respect to price. So he had he said the sort of explanation you might expect a ordinary man or woman in the street to have, that, if you want to get in a higher output, you've got to pay a higher price, without saying, well, why? What's the actual logic behind it? But there were several assumptions that were necessary to get this backstory. And one was the homogeneous product, and I'll talk in quite a bit of detail about that in a later lecture. The other, the price for the single firm doesn't change as its output level changes. Now I want to show where that came from today, because that was just accepted. The intersection of the demand curve and the supply curve is going to be where equilibrium applies. Bing. One curve down, the other curve up. So Marshall's point was just to say, well, that's where the two curves intersect. That's where demand pressure equals supply pressure. Price won't change. But Harrod, I presume most of you are aware of Harrod, Roy Harrod. He attempted to bring dynamics into economics without really having the mathematical skill to do it. But he had quite a few important contributions he made. So he looked at this and said, well, if demand is a falling function of quantity, so to produce more, you've got to drop your price, then P times Q, as the price goes down, you are getting a larger quantity but a lower price. So your revenue is not equal to the demand curve. It's this curve here, DD dash. And he said, let's look at where the source of supply is not small. In other words, they leave out the assumption that if you're so small you can't affect the market price. Said, when that is so, the source has a falling demand curve. And when there's one source, the demand curve is actually the whole market demand curve. And then where it's not horizontal, the output of source is not determined by the point of intersection of the demand curve and the marginal cost curve. And this was not something economists had thought about fully until Harrod worked this out in the 1930s. So gone from the 1890s to the first diagram to the first pointing out that, well, it requires a peculiar assumption to be able to make sure that actually is where the action is. So the demand curve of the market shows the price per unit at which suppliers can find buyers for X units for all values of X. From this curve may be deduced another, which I propose to call the increment of aggregate demand curve. And that was in his notes on supply in 1930. And that became the marginal revenue curve. Now, when you look at Marshall's drawing, you had downward sloping market demand curve intersecting upward sloping market, or downward market supply curve. Hang on, downward sloping market demand curve. That should be a market supply, pardon me. I better fix that. So Marshall drew this downward sloping market demand, upward sloping market supply, and equilibrium at the point of the two. That's the H there. And Harrod, before Harrod made this point, economists weren't fully conscious of how essential the assumption that perfect competition was. Because Harrod showed that if the demand curve was downward sloping, then the firm didn't maximize profits by equating price to marginal cost. And that's what the supply curve is. But by equating marginal revenue to marginal cost. And this is the point I lost too much time trying to work on this, and I'll show you in a moment. So you have a firm with a horizontal demand curve, so the price doesn't change regardless of the amount the firm produces. then what you get is this curve. And this was what I was doing in Ravel earlier today. So there's your demand curve. Sorry, your total revenue going straight up. So the more you sell, the more you make, and there's no decline in the amount you're getting. And you have total costs, which curve down and then curve up more rapidly. Profit is the gap between the two. When you look at the level of output cost per unit, there's price, which is the price you pay. Marginal revenue is also exactly the same line. Then you have marginal cost. Here's your point of intersection. And down here, I've taken the profit curve again and shown that's the maximum. So there's your point of maximum profit from equating price to marginal cost, because price is marginal revenue. But when you have a downward sloping demand curve, this is the result you get. So now I've got the black curve, which is total revenue. Curves doesn't go all the way up, because after a while, the fall in the price overwhelms the increase in the quantity and total revenue goes down. Still the same total cost curve, still the same marginal cost curve here. And you now maximize profits, not where the black line equals the green, which is the larger quantity at a higher price, but where the red equals the green. There's your maximum profit. And the mathematics is quite simple, but economists think they're clever doing this. So you start from the same point. The rate of change of profit is price times differential of price times quantity minus the differential of costs. Expand it out, you now have P times dQ dQ as before, exactly the same term. But this time, this is not zero. This is now a negative number. Okay. So what do you think of this is now marginal revenue minus marginal cost. So this is marginal revenue comes down here, this whole term. This is marginal cost. And what you get out of this is a whole logic which is anti-monopoly. So a huge part of this theory, as well as pointing out how essential it was to have a constant price for the individual firm to get the supply curve. And I talk about that next week rather than this week. It gives you anti-monopoly logic, because if you look over here, the firm maximizes profits where marginal revenue equals marginal cost, that's here, and then prices above that level. Okay, that determines the quantity to produce, that determines the price. There's a gap between the two. So price is greater than marginal cost. Now, from a utilitarian point of view, there is less utility than you could get if you could increase the output level. So the point they want it to be is where price equals marginal cost over here. And it's got a larger quantity and a lower price. So that's the anti-monopoly side of the argument. But the real problem for neoclassicals, and this is why they're so rabid about perfect competition, is that unless perfect competition applies, there is no supply curve. Now, that's ridiculously short, 20 minutes, but that's the whole idea of these lectures, or 15. So I'll go into more, I'll cover them from that point on. Let's have a chat and see what observations you guys have to make. Yeah.
Everywhere you search online, the very simplistic explanation to the supply curve is that one axis is the amount of money that producers stand to make, and on the other axis, the supply that will proceed from that profit expectations. If you go to Investopedia and any Wikipedia or so, no mention to the marginal cost or labor or anything.
Yeah, they tend to gloss over this. They go back to the explanation that Marshall largely had, was if you want to get a higher quantity, obviously you've got to pay a higher price. Yeah, and that's sort of hand waving and stuff like that. It's not really a detailed analysis, and that's one of the pities, because this is why I talk about them being like Ptolemaic astronomers. It's obvious, isn't it, that you see the sun rise in the east and set in the west, so the Earth must be at the center of the universe and the sun is orbiting us. To actually say, no, actually, we're orbiting it and spinning. Huh? We can't be spinning. Look, the wind outside. Imagine how fast the wind would be if the Earth was spinning, etc., etc. So you have to have a really powerful explanation of why all that makes sense to counteract that view. Otherwise, the superficial appearance is all people look at. And, you know, economists are great at amplifying superficial thinking, unfortunately.
Mm.
Alwyn.
And when
Yeah, Poncho. Yeah, no, you come on. Yeah, let's chat.
when robots take over, what's going to happen to the labor curve? Do you know what I mean?
That's a big point. I mean, I don't think we're going to get to the robots. I think we're going to destroy capitalism before we start to employ them on a massive scale. But fundamentally, if we could continue the technological development we're going in right now, robots could replace all skilled labor, all unskilled labor, and a fair proportion of skilled labor could be replaced by AI. So have you looked much at the Tesla bot?
Yeah,
What do
it's
you think of it?
impressive.
Isn't it? It's really
Yeah,
impressive. And it isn't just the fact that it looks like a human scale, which is like the what's the other one? The company
Boston
with the jump.
Dynamics.
So yeah, Boston Dynamics. They've got a dog, which sort of looks like a dog, but that jumping robot they've got, you know, it does great dance moves, but it's so bulky, it's so obviously a robot. And they seem to have focused on the legs rather than the hands. Whereas what um, Tesla has done is focus on the hands and the incredible flexibility of the hands. Has anybody, you've obviously, Poncho, you've obviously seen it. Have you seen the Tesla robot picking up an egg? Okay. So you imagine, like, if you had a mechanical device picking up an egg, and where eggs, of course, vary in size, you'd need to program it. You know, if the egg is this size, then X amount of pressure. None of that is necessary. The bot has feedback mechanisms and sensors in its fingers, so it can pick up something like an egg and not break it. And it's also trained by repetition and by neural networks. So, you know, Tony, you could have had that handed to you by a robot. Okay. So, you know, servants in the home, unskilled labor in the factory, just train them for a while. Then they'll work 24 hours a day. They won't have to go home. Okay. They won't strike. They won't demand wage increases, et cetera, et cetera. So from my way of thinking, if we don't have a universal basic income by the time we develop robotic technology to that stage, there'll be no bargaining power for the vast majority of the population in terms of their incomes. And that's why I get pissed off by the modern monetary theory crowd who are anti-UBI and fight it, so it's not to be a job guarantee. The only guarantee about jobs, I think, in the next 20 or 30 years is they're going to disappear. So unless
But
we have, yeah. Yes, mate.
but the tech overlords are also going to fight for UBI because they need people to buy their products.
That's the other side of things. Unless we have, largely, we're going to be a source of demand. You know, I mean, the terrible, if you think about it, one terrible possibility, if you had, like, you know, you take the technology 50 or 100 years in the future, it'd be quite feasible to be a wealthy couple owning 100 slaves who do all of the work necessary to let them live in luxury, and they don't need anybody else. And therefore, only those who own robots would have any productivity, and the rest of us be back to, you know, firing sticks at animals and trying to eat and stay alive that way.
Well, we can
So
focus on arts and music and research now.
that's what it should be. Fundamentally, when you think about the sort of Star Trek world that, you know, we all look at as a sort of a wonderful TV fantasy, a large part of it is that the replicator makes everything. What the fuck is a replicator? Yeah. But if we actually look at the technology, which is a feasible extension of what we can see being developed today, you'd have a factory consisting of machines, robots, which are specific purpose robots, and all the stuff which has to be done in some sort of finesse would be generalized robots who would walk around and put stuff in particular locations, tighten bolts if they're necessary, know how much to need to tighten them, all this sort of stuff. So labor would just disappear. But that should be a liberating thing for humanity, you know, because we've always been about how do we manage to get intelligent direction of energy to do useful work. And that used to involve first of all, involved grabbing animals and training an animal. Then it involved grabbing the local tribe and turning them into slaves. Then we had about 1,000 years of slave-based societies. Then we had feudalism, where you had to have sense of obligation to the feudal lord. Now we've got wage slavery. And then, finally, robotics. At that point, we don't have to worry about the ethics anymore. So that should be where we want to get to. But, I think we're going to destroy the biosphere before we get to that particular point.
Bummer.
Yeah, and about Alwyn.
I know this is ancient history, but going back to your lecture there on the supply curve and marginality, I'm surprised how little the business community at the time. You said 1890.
Yeah.
Surely business people must have read this stuff and said, "Gosh, this is tripe. We don't do this." Why didn't the business community complain to the economists?
Good question. I've got a feeling that they're just probably maybe not even having an awareness themselves of their own, or not being aware of what the economists were doing. I mean, one of the reasons that economics survives is you don't need an economist to have an economy. Okay? You need engineers to have a physical environment. But if economists didn't exist, that wouldn't have any impact upon capitalism. So if you're busy making a profit and producing new goods and so on, you don't even necessarily read the economists. What you do pick up would be the sort of newspaper level coverage saying capitalism is a wonderful system because it promotes efficient allocation of resources, and all that sort of stuff is all you'd actually be absorbing. You wouldn't be looking at the detail of how they arrive at their assumptions. So I think it's just the fact that they're irrelevant is why they got away with this garbage.
I like that observation, Steve. That's another one of your zingers, that you don't need an economist to have an economy.
Absolutely. I mean, if we needed economists for the economy like we need engineers for bridges, none of this garbage would exist. Okay? It's the fact that they're unnecessary is why they've been so powerful and so successful. And this is one thing which I've worked this sort of idea myself, but my great friend Yanis Varoufakis put a paper out talking effectively about neoclassical economics as a magnificent failure. Because every time it failed to achieve what it wanted to do, it became stronger. Because in some ways, the replacement for the technical failure was a higher level of ideology. And now they're not even aware of how ideological they are. And then what you do have is in the 40s and 50s, you did have fascinating experience where the economists thought they'd get business people in so that the business people can learn from them and they might learn a couple of things from the business people. And without fail, the business people told them, look, we don't have rising marginal cost. You guys you have no idea what we actually do. So there was that feedback. But then by this stage, this is why I'm going through the sort of historical explanation of how it came about in these lectures. The theory had been so ingrained from 1890 to 1930 that they just assumed that firms had these cost structures. And like, this is what I still find one of the most remarkable cameos about how little economists know about the real world is that book by Blinder. I've mentioned the book by Blinder, haven't I?
Yeah.
Asking about prices. I mean, to this day, 25 years after it was published, it still has only one review on Amazon, and I wrote that fucking review. Whereas you've got Maskell, which is this incredibly tedious, 1,000-page thick mathematical textbook that they use for teaching masters and PhD programs, 150 reviews. And like Maskell sort of in the top couple of 100,000 sellers. Blinder's books in the bottom 2.9 million. They just don't read what they don't want to know.
Yeah. Thanks, Steve.
Carlos.
Hi, Steve. Hi, everybody. Steve, I have 3 questions. So I don't know if
good.
I could...
One by one.
Okay. The first one is, I didn't get why do the economic textbooks need to work with small numbers in order to show the view of how the economy works? What would be the problem if they would work with bigger quantities?
Anybody have a guess there? I'm going to see if I'll test you guys out, see if you can work it out for yourselves.
Because big
Anybody
numbers
else?
would dominate the market.
No,
Big numbers would dominate. No.
no, no,
The theory would break down.
no. Oh, no, there's something breaks down, but not the theory.
The graphs break down.
Huh?
The
Huh?
graphs break down.
They do. And you know why?
Probably the curves get very different.
Yes, that's exactly why, because average fixed cost is of necessity is a rectangular hyperbola, F over Q. Okay? Now, if you think about having like a factory for making microchips, F is going to be measured in the billions of dollars, okay? And you divide it by Q, you've got to be talking in the tens of millions of output. Okay, so enormous numbers there. So rectangular hyperbola like that, out to say like a sales level of say, let's say we're talking cars, okay? So like $1 billion factory producing 250,000 units, then you're down to 40, what is that? That's about $400 per car fixed cost or something of that nature. At the same time, your variable costs, which is supposed to dominate, give you that nice looking set of curves, variable costs are going to be some sort of quadratic or something like that. Now, what you will get is fixed costs won't even appear on the axis. Okay? And the shape of the average cost curve will be like that. And so the drawings just don't look good. And the funniest of the good, so therefore they don't know why they do it. They probably, like I did with Excel for a while, fuck around with the numbers. Doesn't look quite right. Oh, that's strange. Oh, you're smaller. Oh, it looks better with smaller numbers. And I can say this is like 1,000, 2,000, 3,000 when I've got 1, 2, 3 on the horizontal axis. Garbage. Okay. If you put thousands there, the graphs look nothing like the textbooks. They're ugly. They're silly. Okay. So that's why. And it's something I only worked out a while ago, but the basic idea is you've got part of costs a rectangular hyperbola, and the other part is some order polynomial. And unless you've got ludicrous numbers in the polynomial, then what you're going to get with those ludicrous numbers, of course, is boom, that's going to be cross here and almost straight up. Okay? And that, again, they can't make the diagrams look like the ones that they draw in the textbooks unless they use tiny numbers. So it's another sign of how it's a cartoon model. Question 2.
Question number 2 is, back in the 1930s, Keynes wrote an essay titled Economic Possibilities for Our Grandchildren. And he argued there that 100 years from that point in time, that people would only need to work 15 hours per week to get everything that they needed. Do you think that Keynes envisioned everything that would happen in terms of technology for him to come up with these arguments?
I think so. I think he was thinking about technological improvement, income distribution not getting skewed, and therefore so much income coming in that you would only need to work 15 hours a week to get enough. But what we've seen, of course, is an incredible increase in inequality. Bargaining power of workers being decimated, unions crushed, and all the surplus has gone to the ultra wealthy. And that's one reason, we've got to think in terms of class terms these days. We've got a class society, and this is Blair Fix has done the numbers on this, which is more unequal than it was during the time of the pharaohs. Okay? The relative wealth of the wealthiest people on the planet is greater compared to the poor people today than the wealth of the pharaoh was to the average Egyptian peasant. So incredible increase in inequality, and therefore we're working as wage slaves. So the 15 hours a week that Keynes envisaged included the technological progress we've seen. I mean, if you go back and take a look at a 1920s movie of, New York or London, let alone a country area or a more backward town, the technology we have these days is just mind-blowing compared to that. But the amount of the workers, people used to work a 48-hour week. Like if you go back to Marx's days, it was a 10 to 12 hour, even 14 hours a day, 6 days a week. The one day you got off was the Sabbath. Okay? So people were working 80-hour weeks then. You then had the reduction in time down to the stage of a 48-hour week, then a 40-hour week, then a 40, then a 35. And at that point, the strength of the union was broken. and we're now going in the other direction. And now people are back to working, people in the gig economy, God knows how many hours they put in, but they've got to put the hours in to get enough to subsistence to stay alive. And then a lot of the money that we thought would be going to people as income has gone into house prices instead. On our one, you're asking if fixed costs are not small in real terms. No, fixed costs in Blinder's survey, and again, I think Blinder's survey understates the important stuff because he's a neoclassical economist, and all these students who did the interviewing with him are neoclassicals. They didn't comprehend what they were being told, so I think they underplayed the stuff which differed from their own beliefs. But even they found that the average level of fixed costs at the operating level of a firm was about 44% of total costs. Carlos, third number.
Last one.
Yep.
Do you think that embarking on the project that Blinder did back in the 1990s, doing that project today, do you think that would help moving economic analysis on the right direction?
No, they'd ignore it again. I mean, Blinder, think about Blinder's status. He was a vice president of the American Economic Association and a vice chairman of the Federal Reserve. You couldn't get much more establishment than him. Okay? And they ignored him. Okay? They ignored his paper completely, ignored his book. So they're so conditioned into thinking this is the way the world is, that if somebody says it's not, they don't look down the telescope. It wouldn't change a thing.
Okay. Okay, thanks, Steve.
Okay, Tony.
I think the business schools understand more than the economists, thinking back to some of the lectures I had.
Yeah, that'd be right.
One of them, it was giving us some figures for manufacturing syringes for healthcare services.
Okay.
And they gave us the costs for manufacturing them and the numbers they needed to do, what the world demand was, and therefore how many factories did we need?
Right.
And it was 3, because they had
3
to use billions of them
3
to provide for those factories to be cost effective for a company to build them.
3
Because their fixed costs were so phenomenally high, they needed huge volumes.
Yeah. You look at things like, in microprocessor chips. I mean, the machine that makes, I think it's ASLM is the spin-off from Philips, the Dutch company that produces the most precise focusing lithographic machine on the planet. No other company comes close. And it's $250 million per machine. And you need apparently at least one of them, if not more, per factory. Well, that one machine is $250 million, and then you've got to have that machine's got to be in a clean room, so the level of you can't have a single micron of dust in the air. So you've got to be evacuating. The temperature's got to be temperature controlled, and the water's got to be ultra clean, because of what is used for the focusing process. Enormous levels of costs to set the environment in which you can produce these chips at an incredible scale. So one company making them, I think about 5 or 6 companies buying them. It's incredibly concentrated. And yet with this stupid myth of perfect fucking competition, which is supposed to have thousands of firms or tens of thousands of firms, it's just absurd. And that's why I've got past the point of being polite to any neoclassical. It's really talking to somebody who needs remedial education.
And the other one from the healthcare background, we used to contract with the manufacturer for a provision of some expensive things. They were about £2,000, £2,500 each at maximum, and the cheapest ones were about 500. But that's the prices we were quoted from the firms. But the NHS wanted us to buy them through their centralised purchasing system. They were 20–30% more expensive. And we
Which
said
shouldn't happen.
Why the hell can we get them cheaper? Because we're one place, and the NHS is the whole of the country. He says
they should be getting it cheaper.
Numbers.
Sorry, what?
You guarantee numbers.
Oh, right. Okay.
The NHS wants to have them, but it won't tell us how many it's going to buy.
Oh, good grief. So they consequently put their markups up to handle it.
They just got standard price.
Yeah. Tragic. It's incredible. I mean, capitalism survives because of its sheer momentum, not because we know anything about it. And that's why I think it'll come tumbling down the same way, unfortunately. So next week I start getting into the what cost structures actually are, which will be good fun. I hope I get this bug out of the way as well. I'll see if I can get actually. I know I can't. I haven't quite got it working again yet, but I tried to do this with Excel, and it was a nightmare because you had to be using crazy dollar symbol cell reference formulas to make it work, and I needed one page for monopoly and another for perfect competition. And I finally thought, hang on, if I can just import a column of numbers and call that quantity, I can probably do it all in Ravel. And then I was looking forward to showing you guys, and then the damn thing crashed on me. But I have got a snip of it, so I'll see if I can actually show this here. Yeah, let's see. Okay, so I'll just actually share screen again. So that's doing it in Ravel. So I imported quantity, and so I've got the numbers coming in from firm input output here. That was another crash. I'd freeze it at that point. All that is just a column of numbers 1 to 50. So that's my quantity. And then I've got variable costs being A times quantity, which is the not the linear term, but the first power term in a polynomial. Then that's negative. So that's why I've got declining marginal cost initially. That's what's turning up over here. Then I have linear power term, a squared and cube. That's a cubic. That gives me variable cost. Add that to fixed cost to get total cost. Take the change in variable cost, I get marginal cost. And then the demand curve is a price at 0 sales minus the slope of the supply curve multiplied by quantity. In this particular case, I'm showing perfect competition there, so there is no slope. But then the price times quantity give you total revenue. Change in total revenue is marginal revenue. And they've got total revenue minus total cost is profit. It's all readable, unlike a set of Excel formulas. So even though I didn't think I could target Ravel at this sort of audience, it's actually easier to do these sorts of silly neoclassical graphs here using Ravel than it is with a spreadsheet. But I'm sure they all use spreadsheets. So what I could then do, and I had this lovely little demonstration of it, I could change the slope of the supply curve and these graphs would update, and you then see the impact, the changing levels. So I was hoping to show that to you, but as I said, the bloody crash came through. So I'll try to get that working for next week so I can show it to you properly. But Ravel's getting close. Yeah. Oh, by the way, that reminds me, there's a new version out, and I'll just actually, I'll load a data file with it rather than trying to load a illustration like that. Let's just see. I'll try this one. So what we now have, rather than a dedicated tab for plots and a dedicated tab for godly tables and so on, we simply have a publication tab, and you can click on that and see what's in the publication tab. And you can also create additional tabs. So I'll call this Fred, for the heck of it. So now you can say, I want to place this on Fred. So I right click, add item to tab, call it Fred, and I go to Fred, and now I've got the object there. And I can then lay out a document to explain the logic of a model with several different publication tabs for different purposes. So if I add that to publication, then that graph is now on publication. And I can go and say, let's add this one as well. And you can also zoom in and zoom out, which wasn't possible beforehand. I don't know that these buttons don't work yet. Oh, that one does. The full screen doesn't work yet. But this is all the stuff that Russell has to work on. And then you can export that out in whatever format you like. SVG is a vector graphics format. There's PDF, PostScript. So you can produce graphs and use them in documentation. So it's really feeling like it's getting close to being a saleable product that people will be wowing about, rather than saying, oh shit, it crashed on me again, which is unfortunately still happening. Yeah. And by the way, back to your business school combination, Tony, a lot of Marxist economists end up working in business schools. They couldn't get a job in economics, or they got driven out. But because they were realists and they were normally good teachers, they got a job in business schools. So one of the places that non-orthodox economists survived was business schools. Ironic, but that's true.
The course I did at Manchester Business School was a 3-week course, and basically it was full-time, 12 hours a day for 3 weeks. So they did virtually a whole MBA in 3 weeks.
Oh, yeah.
It was absolutely brilliant.
Mm.
But I did it during the time of Black Wednesday in the 90s. And
oh, okay.
I remember going in on the lecture on the morning on having a finance session, and he just started off by saying the government hasn't got a clue what they're doing. And we said, what do you mean you're supporting the pound? He said, they're putting 20 billion in. He says, how much does the pound exchange on the financial markets on a day? And we said, what, 5 or 10 billion? He said, 500 billion. He said, they're pissing in the wind.
Yeah, yeah, and he was right. Yeah, that's the escape for realists from neoclassical fantasy. Used to be business schools, probably still is. So you get the good stuff there, and you get the shit in economics departments. And of course, the economists were happy to see that lot go, because then they could do more of their modeling, you know. So it became even more unrealistic after the critical people were chucked out. Tragic. Yeah. Are we done? Dave, you just turned up. I'll see you again on Friday. We'll organise.
I got a work meeting, so
that's okay. I've had a freezer of names. Jordan has told me he's ill right now. I hope he hasn't got COVID, but he says quite sick. So he may be a bit slow in putting up the lectures, but he is doing all that sort of stuff. So the recording hopefully will be up tomorrow sometime. Okay. If it's not there, it's because Jordan's still crook. Hopefully he's doing okay.
no problem.
All right, guys. Good again. Great to see you. Dave, see you on Friday, and we'll keep on rolling. See some of you tomorrow as well. Bye all.
Thanks, everyone. Thanks, everyone.
Bye.